Hello and welcome to Physics 1401 again. Today I want to talk about an example that has to do with velocity versus speed. Mainly, I'm going to find the average velocity, average speed, and instantaneous velocity and instantaneous speed just by looking at a position time plot, such as this one. Okay. So there are intervals, as you can see. So let's start with the first interval between 0 and 5 seconds. Between 0 and t equals 5 seconds, we see a gradual increase in the position of the object, and there's a constant slope, which indicates constant velocity and constant speed. So for that segment, actually there's no difference between average velocity and instantaneous velocity because of the straightness of the line. But let's find it. So average velocity is by definition delta x over delta t. Right? The displacement divided by the time interval. So we go from 10 meters to 20 meters. Final x minus initial x divided by the time. So 5 seconds minus 0. That gives us 10 meters per 5 seconds or 2 meters per second. Okay. So that is the average velocity. And for this segment only, it is also equal to instantaneous velocity. Instantaneous velocity, say at 3 seconds, or 2, or 1. I could say including 0, but not at 5, because we have a sharp corner at 5. You know, we don't know what the slope there is, so let's leave 5 out of that. But within that interval, between 0 and 5, there is just one velocity, and that is also equal to the average velocity. And speed is the same. That's also equal to instantaneous speed and average speed. Instantaneous also equal to speed for that segment. But now what happens between, let's say, 0 and 10? So in part B, the interval is from 0 to 10 seconds. As you can see, there are two segments. So, two straight line segments. Actually, we have two instantaneous velocities. Instantaneous velocity at 3 and instantaneous velocity at 8 seconds, for instance, are definitely not the same. But how do we find the average velocity? Let's start there first. The definition still applies. The average velocity is simply the displacement divided by the time interval. Delta x meaning, if you write explicitly, x final minus x initial divided by time interval. X final is negative 10 when t is the final time, right? So x final is negative 10 meters. That's the position when t is 10 seconds. Minus the initial position, and that was 10 meters. So that's the numerator. In the denominator, we have t final, 10 seconds, minus 0. So this gives us negative 20 meters per 10 seconds, or negative 2 meters per seconds. Okay? So this is actually nothing but the slope of the line that would join the beginning and the end points for that interval, meaning this dashed blue line. The slope of this blue line is nothing but negative 2 meters per second. That is the average velocity. Okay, so what about the instantaneous velocities then? In that interval, I said we have two. So the instantaneous velocity, let's say at t equals 3 seconds, we already found it. That's 2 meters per second. But to find the instantaneous velocity, say at 6 seconds, then we have to consider the slope of the second segment. So this will be equal to a slope here of the second negative slope, right? So what do we have here? We have rise over run. So we have negative, it goes from 20 to negative 10, right? So we have negative 10 minus 20. And we're talking about a time interval now from 5 seconds to 10 seconds. So we have negative 30 divided by 5, right? So negative 6 meters per second. Okay, so we have two instantaneous velocities. 2 meters per second in the first one. In the second one, we have negative 6 meters per second. All right, so what else can we do in that time interval? Speed. Let's consider speed. Let's consider speed. So the instantaneous speed when t is 3 is the same, 2 meters per second. But the instantaneous speed when t is 6, 7, 8, 9, 10, okay, in that interval, pick any time in that interval. So let's say when t is equal to 6 seconds, the speed will be just the absolute value of the value we found earlier, which is just 6 meters per second, because speed is always positive. It doesn't matter which direction you're moving. Okay? Now, a negative sign for velocity means you're moving in the negative x direction. Positive, right? So, speed can't tell you that. It's only velocity. So what is left? Average speed. Let's find the average speed now. The average speed in an interval, of course, from t equals 0 to 10 seconds. Well, this will be this will not be the displacement divided by time. It will be the total distance traveled by time. So distance over time. So in the first 5 seconds, the object goes from 10 meters to 20 meters. What's the difference? 10. Okay, so 20 meters minus 10 meters. That gives us 10 meters in the positive x direction. And then in the second phase, or second segment, from 5 seconds to 10 seconds, the object moves in the opposite direction. For how long? Or for how much distance? From 20 meters mark all the way back to negative 10 meters. So 30, right? 30 meters. 30 meters. So we can write it as 20 plus 10. And this happens in 10 seconds. Alright, so this is 10 meters in one direction and 30 meters in the other direction. In total, 40 meters over 10. This gives us 4 meters per second. That's the average speed. Now this indeed happens to be the average of 2 and 6, but that's not always the case. Okay, so this happens like that in this case because we have equal time intervals, 5 seconds intervals, but that's not always the case. So never add the speeds and divide by 2 or 3, whatever segments you have, Don't do that. That would be a mistake. Okay, so I think you get the idea, but let's add one more part to this problem. How about, let's say, the average velocity, let's say part B, average velocity in a time interval from 0 to all the way to 16 seconds. Okay, the definition is displacement divided by time. Now it goes forward 10 meters, it moves in the opposite direction for 30 meters, and then 20 meters again from -10 to 10. It ends up actually where it starts. Okay, so the displacement is 0. So x final is 10 meters, x initial is also 10 meters. You divide this by 16 seconds and you get 0. The average velocity is 0. Is the average speed 0? No, it's never 0. Okay, average speed. How do you find average speed? You just have to add one more term. Let's do it here. Average speed. Now, we already know 10 meters in one direction, and then 30 meters in the opposite direction. We already talked about that. And finally, we have 20 meters in the positive direction. You add all them up. Add all of them and divide it by 16 seconds. This will give you the average speed. So I hope this one helps. Till next time, goodbye.